Okay, in this chapter, we're just applying function notation, so some more application questions. So if we look at this example here, the volume of a sphere of radius r is given by the formula v. So the function of v in terms of r is equal to 4/3 times pi times r to the power of 3. Okay, so it's like we've got a function, and if we wrote this as a function, like instead of using r, we used x and things like that, so we would have like that, and it'd be x cubed. So when they ask for the practical domain of the function v, they're pretty much saying what values could r be, what values r can be, is pretty much the practical domain. So if we're going to have the radius of a circle, well, obviously we're not ever going to have a negative. So we will never have a negative, and it can't be 0 either, because a 0 wouldn't then the volume or the circle wouldn't exist. So the domain's going to be greater than 0. So I'm going to use a curl bracket, so it doesn't include 0, but it could be any other number above that, a positive. So I'm going to go up to infinity and there. So pretty much what I'm saying is the radius cannot be 0, because we'd have nothing, or negative. So we can write that in set notation like I've done here. Okay, now they've also asked me to find, it should have been read find v of 10. I'll just fix that up. V of 10. So if I go to find v of 10, all you have to do is everywhere you see the radius, you're going to put the number 10. So it'll be times 10 to the power of 3. So if we times that out, now because in methods we like to have exact answers, so we'll just leave the pi as pi. So 10 to the power of 3 is 1,000 times 4, and then over 3. Okay, let's do the next one. So if we have when it says if r is the real field is, so all the numbers in this case can be anything from the real field. That's what this is saying. All right, and we've got a function, and it's following the ax plus b basic formula. So they're saying it's that. So we know this is a linear function because the highest power is a 1, which is a straight line. So they've told me f of 1 equals 7 and f of 5 equals 19. So find a and b and sketch the graph. So what you can do is you have two unknowns, which is when we have two unknowns, so we've got a and b. So we need to be able to set up two equations. So we can do that. If they've told me that f of 1 equals 7, therefore I can write out the equation. I could say that 7 equals a times 1 plus b, and I could simplify that to be 7 equals a plus b. So I've got one equation there. Okay, and then I could use the other one, f of 5. So they're telling me equals 19. So I could write that out. So therefore 19 equals a times x, but x is 5, plus b. So I end up with 19 equals 5a plus b. And here I have equation 2, another equation. So then I might solve them simultaneously. So if we solve them simultaneously, we might look at them. So if I write them underneath each other, So when we do the method of elimination, we want to, if we minus it, do we get rid of 1, which we do. So if I do 7 minus 19, I get negative 12. Then I do A minus 5A, I get negative 4A. And B minus B equals 0. So I end up with negative 12 equals 4A. And if I keep solving for A, so I get 3 equals A. So now I know what A is. I could use any one of these formulas to find B. So I'm just going to use the 7. So if 7 equals A plus B, but I know A is 3 plus B, then 7 minus 3 is B, so 4 equals B. So if I was to write out the function, I've got the function is now, we know, is 3x plus 4. So if I go to sketch that, we know that is a linear, so it's going to be a straight line. So yeah, it's got a y-intercept of 4, so I might say negative 4 there, and it's a straight line, so it's a positive gradient, so I might, use a ruler. So there we got y equals 3x plus 4, and we might sketch all of that. And there we go, so y, x, negative x. And we should just practice in finding the x-intercept. So that would be when y equals 0. So that would be negative 4 on 3, comma 0. And this point up here is 0, 4. So just if we're putting all the details onto our sketch, that would be good. All right, so let's have look at another example. So find the quadratic function f such that f of 4 equals f of negative 2, but they also equal 0. So when you say that, if you're saying, when they're saying, when, this is what they're saying when x equals 4, the function is 0. And then when x is negative 2, the function is 0. So that means, remember, if we have a quadratic, and we have y equals ax squared plus bx plus c, the basic one, when we say if that the function equals 0, we're pretty much saying, well, y equals 0. So we're saying y equals 0 when x is 4 and x is negative 2. So essentially, we have found the x-intercepts there. Okay? So there's a couple of ways we could do it. But we've also got this piece of information here. We've got when x equals 0, the function equals 16. So that's like saying when x equals 0, y is 16. So this is the y-intercept. Okay, so we need to write the function. So let's think about, we have the basic formula up here, but because I've got the intercepts, I might try doing the intercept method. So there would be some dilation factor, but here would be the x-intercepts. If the x-intercept is 4, I must have had a factor of x minus 4. And if the x-intercept is negative 2, I must have had an x plus 2. Because I would have let those two equal 0, these two factors equal 0, and I would have got these intercepts. Alright, but we need to make sure, we can't assume that there's no dilation, so we need to know that. So I might use the piece of information here. So when f of 0 equals 16, so when x is 0, y is 16. So I could write 16 equals a, 0 minus 4 times 0 plus 2. So I end up with 16 equals negative 4a times 2. So 16 equals negative 8a. 16 divided by negative 8 equals a. So negative 2 equals a. So there's a dilation factor. So I could say the equation is y equals negative 2x minus 4 x plus 2. And there you go. So they didn't say what format. If they wanted it in this format here, ax bx plus c, just expand all this out and then keep going, and then you'll get that. But they didn't ask, so I might leave like that. There are other ways you could have solved this. We could have set up two simultaneous equations again, and we could have known that it was the y-intercept is 16. I'm not going to do that because we did that one in the question before, but you could do that.